Okay, so let's discuss boilers. So in combustion engineering and in a lot of power plants and even industrial plants, we often use boilers for energy or power generation as well as heat generation. So some can be used for electricity, some can be used for example, is heating as well, heating gas, like this. So we want to characterize what are the important parameters of boilers, so we compare one boiler to another, and so on. What is the efficiency of the boiler? So on. So if we have a boiler, we can deduce that we have mass entering in our system. No? So in here we have the mass of the steam entering with the enthalpy of HF. And then the mass of the steam is also exiting this boiler in this value with this enthalpy. Now, it won't be superheated or saturated if we don't have an input heat. So we have to input the heat in terms of the heating value of the fuel times the mass of the fuel. Okay. So therefore, if we recognize this, then the efficiency of the boiler is the output over the input. So the output is how much steam is generated basically over how much input of heat is into this I mean, into the boiler. So that's basically it. No? Capacity lang ng boilers. But there are lots of characterizing values for boilers. We have the rated boiler horsepower. Generated by fuel is just the mass of fuel times rated value, but we start with the rated boiler horsepower. So the rated boiler horsepower is just a metric for how much surface area does this boiler have. No? So for water tube, and these are both in SI, no? Metric units. No? So if you have your heating area, no, it can be found, which is basically just the surface area of your boilers. If you divide this by 0.91, then you get the rated boiler horsepower. So this is for water tube, no? So remember that in water tube, the one in the middle or the one inside the pipes is the water, and this is your fire outside. For fire tubes, we have the same thing, but this is divided by 1.1. For fire tube, we have the fire inside. Water is outside the pipes. Okay, so for English, you can also use this. Although there are a few problems with units, no? It is not exactly this. No? But if you have an English, the given area is in square feet, we just divide the area by 10 to get the same rated boiler's power, same for fire tube. So for fire tube, you have the area over 12. Oh, okay. And then moving on, we have the developed boiler horsepower. So in historically, uh, a lot of engineers devise or think or probably thought of a way to compare steam engines from one another. So we already know the mechanical horsepower, which is 0.746 kilowatt, which is 1 HP. But in boilers, it is different here. No, it is not 746. But the definition of boiler horsepower is how much energy is required to produce 15.65 kilogram per hour of steam. No? At 100 degrees Celsius. So how much energy is needed to produce 15.65 kilogram per hour of steam at 100 degrees Celsius? Or in other words, you can also say this in English, you have 34.5 pounds per hour. So that's the same basically. 212 degree Fahrenheit. So if you calculate this, basically 35322 is just 15.65 times HFG at 100 degrees Celsius. So basically, this is I know this is 257. If you multiply 2257 by 15.65, that will be 892. So be wary that the mass flow rate here is in kilogram per hour. Okay. So we have the developed boiler horsepower. And then moving on, we have the evaporation units. For the evaporation units, this is just the mass flow rate times Hs minus HF. So basically, the output. So the mass of, the enthalpy of steam uh, exiting the boiler and the enthalpy of chilling the still and liquid water entering the boiler. So for the percentage rating, you have the fraction of PPH or developed boiler's power or the rated boiler's power. And for the factor of evaporation, so we have the same constant here, 257 from here, which is HS minus HF over the 257, the factor of evaporation. So this is just a comparison of how much energy is needed to evaporate at 100 degrees Celsius. Okay, so we have the boiler efficiency and then the net boiler efficiency. So if we have auxiliary power that is needed, for example, pumps, so we have to include the pumps in the boiler efficiency. And then we have the actual specific evaporation. The definition is just the mass of steam over the mass of fuel. For the equivalent evaporation, this is just the factor of evaporization times the mass of steam. You have the equivalent specific evaporation, which is just the mass of steam over the mass of fuel times the factor of evaporation. Oh, sorry. Yes, factor of evaporation. And then the boiler efficiency in terms of TSD, TSC, and FE. So if you combine everything here, we can also say this. So the boiler efficiency looks like this, but as you can see, this is AST, right? I think I'll take note of this. Okay. So the boiler efficiency is just MS over MF, right? And then you have QH and this left. So the factor of vaporization, as we know, no, is equal to MS minus MS, but HS minus HF over 2257. So we can say that HS minus HF is just 2257. So 2257 multiplied by FE. No? And then what's left? QH. So for QH, where's QH? QH. So QH is here. So divided by QH. So multiplied by 1 over QH. So if you simplify this, it's just ESD. You just write this as ESD and then multiplied by S1. Okay. Okay. So that's it. Thank you guys for listening.